Okay, question 6. We've got a circle with a centre 7, 5. So that's this point A, and it's intersecting with a tangent at the line y equals 2x plus 1. We need to show that the equation of the line P to A, so this line here, is 2y plus x equals 17. The first thing to note is the gradient of this line. The gradient of PA is going to be the negative reciprocal of this line, so it's going to be minus a half. Then we can use the equation for a point on the line, so we could either use P, but we don't know what P is, or we can use A, so we're going to use 7, 5, and do y minus y1 equals mx minus x1. So y minus, it's going to be 5 is equal to m, so then negative a half times x minus 7. And times by 2, so 2y minus 10. Expand these brackets, so that's minus x plus 7. We're nearly there now. We need to move the 10 to the right, so that's going to be 17. Move the x to the left, that's 2y plus x. So that's what we were after for part 1. Okay, for part B, we need to find the equation of the circle. In order to find the equation of the circle, the easiest thing to do is get the centre point, which we've already got, and the length of the radius. So if we can find the length of P to A, then we'll have the radius, and that's going to help us find the equation of the circle. How do we find the length of of P to A though? We do need to know the coordinates of P. So that's the next job, is to find P's coordinates. P's coordinates will be that it's the point of intersection of these two straight line graphs. So if we solve those two lines simultaneously, so y equals 2x plus 1 with 2y plus x equals 17, I can substitute straight in 2x plus 1 for y into the second equation. So 2x plus 1 there plus x equals 17, and that's 4x plus 2. That's 5x is equal to 15, so x is 3. We need to find the y coordinate, so when x is 3, y is 2 lots of 3 add 1, so that's 7. So P is 3, 7, and we already know that A was, what was A? A was 7, 5. Distance between 2 points, this is your year 1 work, this is coordinate geometry right back from year 12. The length of P to A, you might write that as magnitude, is going to be Pythagoras, is going to be x1 minus x2 or x2 minus x1. So in other words, the difference between the x coordinates squared, so 7 minus 3 squared plus 7 minus 5 squared, the difference between these two. It doesn't matter that I've got them the wrong way around because I'm going to square them anyway. And that's going to be the square root of 16 add 4, so root 20. That then tells us the equation of the circle. The equation of a circle is always the centre of the circle. If the is x1, y1, then it's the negative of the coordinate. So we're going to have x minus 7 squared plus y minus 5 squared is equal to r squared, so root 20 squared, which is 20. Part C wants us to find the other tangent line. So we've got this tangent line here. There's another tangent line that runs parallel to it. That's a terrible tangent line here. So it will have the gradient of 2 like the other one did, but we don't know. It's going to cross some negative y value, which we need to find out. This is actually a much easier question than you would realise. What we can do is use the fact that the difference between getting from P to A is going to be the same as the difference between getting from P to, say, this point Q. So P, we know, was 3, 7. A is 7, 5. So we've gone, to get from P to A, we've gone 4 right in the x direction. So I'm going to need to go another 4 right in the x direction to get to Q. So that's going to be 11, and we've gone 2 down, so we're going to need to go 2 more down. So Q is 11, 3. It's that straightforward. It's not a trick. That's all you needed to do. Some of you were finding, like, trying to do points of intersection and lines meeting curves and saying that there's only going to be one solution, so the discriminant would be 0 and all that stuff. You don't need to do that. It's not that difficult. This is what they were after you doing, which put a few of you off. So we now know that Q is 11, 3. So if we do y minus y1 equals mx minus x1 again, using the gradient of 2, we can do that y minus 3 is equal to 2 lots of x minus 11, and just expand the bracket. So y minus 3 is 2x minus 22. Y is going to be 2x minus 19. So k is negative 19. That's all they wanted for that one.